An investigator is conducting an experiment to develop a new drug against HIV infection. HIV-infected and uninfected CD4 T-cell lines are mixed with in vitro with a chemically modified synthetic peptide triazole complex. The complex is found to have a high binding affinity to the GP120 protein, irreversibly inhibiting its function and reducing CD4 T-cell infection. Inhibition of which of the following steps of HIV infection is the most likely therapeutic effect of this experimental drug? Option A, incorporation of viral genome into the host cell DNA. Option B, transcription of the viral genome. Option C, fusion and entry into CD4 T cell. And option D, assembly of the viral particles. Option E, attachment to host CD4 T cell. Okay, so yeah, here this question is also interesting that, you know, GP120 protein, you have to understand that there is something called GP120 protein which you need, you know, the HIV enveloped glycoprotein, it is called GP120, binds to CD4 receptor on host T cell. Okay, they bind and they enter cells and macrophages. GP120 function as a docking protein for the virus and is essential for infection of the host cell. A drug that inhibits GP120 would inhibit the attachment of HIV virus to the host cell. You know, there's two drugs, maraviroc and enfuvirtide. No, so maraviroc helps, you know, it inhibits GP120 fusion with the CD4 T cell. Okay, so keep it in mind whenever you will go through the pharmacology question, they're gonna ask it. Okay, so it's a maraviroc which does not allow the GP120 interaction with the CD4 T cell. Okay. Okay, so why it is A is incorrect? It's saying incorporation of the HIV genome into, no, so why A is incorrect? Incorporation of viral genome into the host cell. You know, once the HIV virus enter your cell, what happens? They try to incorporate in the host cell, and that is done by integrase. Okay, not this integrase enzyme is there in our body. No, so incorporation of HIV genome into the DNA of host CD4 T cell is mediated by HIV enzyme integrase. Inhibition of this step is the mechanism of action of integrase inhibitor, that is raltegravir, dolutegravir, albutegravir, you know, integrase inhibitor. They inhibit this process. The experimental drug described in this vignette has high affinity for GP120, which has a different role in HIV infection and pathogenesis. Okay, so here option, I think we were option B. Yes, so option B, after HIV has infected a host cell, the HIV enzyme reverse transcriptase is responsible for transcription of the viral genome from RNA to DNA. You know, once they make their DNA, okay, they incorporate into the host genome. Okay, inhibition of this step of HIV replication is the mechanism of action of reverse transcriptase inhibitor. Okay, so it is the reverse transcriptase inhibitor enzyme which is going to inhibit this process, that is reverse transcriptase process. Okay, that is, you know, nucleoside reverse transcriptase inhibitor, you know, non-nucleoside reverse transcriptase inhibitor, NRTI, NNRTI. No, so the experimental drug, so it is not the answer. So now, which drug is responsible for fusion and entry into CD4 T cell? You know, it is, I know I said two drug, that's maraviroc inhibit attachment of virus into the host cell, and enfuvirtide is a drug which inhibit this process. Okay, C. So the fusion and entry of HIV into CD4 T cell are mediated by the HIV enveloped glycoprotein GP41. Okay, GP41 is responsible for fusion and entry. Inhibition of GP41 would result in decreased HIV fusion into the host cell and is the mechanism of action of fusion inhibitor like enfuvirtide. Okay, so keep it in mind. This is an important question. You know, correlating pharmacology. The experimental drug, this is not the answer. No. So now I think we have explained. So assembly of viral particle. What helps in assembly of viral particle? HIV protease. No. So what happens once the proteins are very big? Okay, whenever they are synthesized, they are very big. So protease enzyme, they break it into a small particle and they help in assembly. So protease inhibitor, suppose whenever you give protease inhibitor, what happens that, you know, are able to synthesize the protein, but they are unable to assemble themselves in a new virion. Okay, that is what gonna happen. So HIV protease mediator, you know, fusion. So what happens once viral particle is synthesized, it should be assembled into a new virion. Okay, and there is, for that function, virus have some enzyme called protease. Okay, if you inhibit that enzyme, they cannot assemble themselves into new virion, and that drug the drugs which prevent this process, it's called protease inhibitor. Okay, indinavir, these drugs are protease inhibitor drug. Okay, so keep it in mind. That's why you give combination drug, like we give heart therapy, we give nucleoside reverse transcriptase inhibitor together with protease inhibitor together with integrase inhibitor, because if virus is become mutant at one step, then the second step you have 2 drugs, 3 drugs, so they're gonna work on different stages. Okay, so if virus become mutant to resistant to the nucleoside reverse transcriptase inhibitor enzyme, then you have another drug, protease inhibitor, that's gonna work. Okay, if it become resistant to that step, then you have another drug, integrase inhibitor. So that's why we give in a combination rather than a single drug. Okay, in HIV actually it is CCR5 and CXCR4. Okay, CCR5 and CXCR4, one is present on macrophage and one is present on T cell. Okay, so what happened, even so what is the problem in HIV? The virus infect T cell, and T cell is responsible for production of antibody. So what happened, virus is going to kill your T cell, you don't have antibody. So virus, HIV itself is not a disease, it is a it's what it do, it kills your immunity. Your body can't make antibody and they can't fight against the infection in our day-to-day life, and patient going to die due to infection rather than HIV. So what happens, for the entry of the virus into the T cell, they need 2 receptors. The primary receptor is CD4, but the co-receptor called CCR5 and CXCR4. If there are some patients who are immune, who don't have this receptor, so what happens, if they get HIV infection, the virus cannot enter their body. Okay, so there is 2 situations. If the patient is homozygous to the mutation, he does not have CXCR4 or CCR5 receptor at all, he will never develop HIV, AIDS. Okay, and if he is heterozygous to that mutation, then it will take a long time for the person to become immunodeficient. He will have HIV infection, but it will take a long time. Okay, because of that mutation. So keep it in mind. It is a latest discovery that what happened, there was one patient, he was being treated for HIV and he develops for some reason he need bone marrow transplant. A doctor did bone marrow transplant, but after a few days, what the doctor noticed, that his viral count is decreasing without treatment, and there was no more virus in his body, and doctor was surprised. So how it happened, and they traced the patient from the donor who donated their bone marrow, and what they found, that the donor did not have CD4 CXCR5, and he was mutant resistant, he does not have that receptor. So, and he gave whenever the recipient got that transplant, now even he is producing T cell, the new T cell does not have CXCR4 and CCR5, due to which he is resistant to HIV. Okay, so it is the latest discovery. Doctors are working on it, and they're going to ask you this question.
Thanks for watching. Please give a thumbs up and subscribe for more.